Hello, so we're back, and this time we have a proper nice laptop to repair. We have a Asus TUF Gaming AX7, I believe. A17. Anyway, Ryzen 7. Yeah, a nice gaming laptop. Now, let's check the customer email, and actually, let's check the customer picture. That's what I want you to see. Now, let's say the customer it will send you this picture. What you will do? That's my question. You will take the job or not? Hmm? Because clearly, what you see on the picture, we have a shorted Mosfet. No sure if it's on the GPU or on the VRAM, but you will get a job like that. Hmm? And what I said to the customer, sure, I can have a look, but the picture is quite scary. And it's not because of the burn MOSFET, it's because whatever is connected to that MOSFET is probably shorted. Most likely CPU, GPU, but it's up to you if you don't mind my £25 diagnose fee. Sure, feel free to send it anytime. I mean, just saying no, it's kind of rude to say, no, I'm sorry, I can't take the job, probably I can't fix it, and yeah, I don't want it on my desk. Kind of rude. If the customer, he's willing to spend £25, yeah, I can have a look. I mean, on this case, probably we can even make it work on the integrated graphics. If it's a GPU MOSFET, and I believe it's a GPU MOSFET, or VRAM, doesn't even matter. Anyway, let's open the laptop and let's have a look. The laptop doesn't have screws inside. I mean, you have to understand the dynamics of, of this kind of disaster, because this is a disaster. This is something which your laptop, it will never come back. A power rail, like low voltage power rail, just got like 19 volts with a bunch of amps. Now, of course, whatever is connected to that power rail, most likely is dead. So, lol, I can't believe, actually, this is a seal. No one took out the heatsink. And here is the customer picture. Let's have a look under the microscope. Yeah, and we can see the customer cleaned the burn MOSFET. You know what? The customer missed the capacity. This one is cracked. Check there. Probably the main power is still shorted. If he will take, I mean, I can see it's clean. Probably if you will remove this capacitor, it will have a working laptop. But let's check together the main power rail for short. So the main power rail, check there, 1 ohm. And 1 ohm, I believe, because of this cracked capacitor. Not sure if you can see it, it's cracked. Probably you can't see it. Yeah, I'm really sorry for the focus. Yeah, the capacitor has a crack. Because this one is too burned in order to be... Oh, and the layers are burned. Anyway, let's remove that capacitor. Removing the capacitor. Let's see if we still have short. I'm curious. Plus, minus, and it's not short. So if the customer, it will remove... What happened with my multimeter? Oh, okay, okay. Okay, now it's fine. If the customer, it will remove the capacitor, probably the laptop, it will work fine. I mean, it will work on the integrated graphics. Let's remove this MOSFET. Because I'm still confused about the configuration here. I mean, this track is not connecting anywhere. Where is this connected? No, I can't remove it. It's welded. No, I can't remove it. No. So one second, because I'm confused. Oh, okay. So here we have the gate, here we have the source, and this one is the drain. Okay, now it's making sense. Yeah, so we have two high sides MOSFETs, or we have two different power supplies. Yeah. Oh lol, I don't have this charger. Anyway, let's plug the battery. Hopefully the battery has some power on it. No, I don't have Asus chargers. Pressing the power button, nothing happened. Coming with a power supply, add the charging port. Yeah, here. Yeah. And nothing happened. And if I press the power button, it's taking 1.6 amps. We should have picture, yeah? Yeah. We should have picture. 30 milliamps. 1.6 amps. Let's wait, yeah? Because most likely the customer reset the BIOS. I mean, hopefully I don't have a current limit. We have picture! We fixed it, I can't believe, huh? We took out the capacitor and it's working. Yeah, but it's working on the AMD Radeon integrated graphics. Yeah, it's the VRAM. Yeah, it's nothing what we can do. VRAM has like 4 ohms. Here the VRAM should be like 60, 70 ohms. Yeah. Sadly, it's nothing what we can do. You will not see VRAM having 4 ohms. No. No way. Check that, 4 ohms. Basically dead. All VRAM is shorted, plus the VRAM memory controller from inside of the GPU, which is taking power from this power supply. And the GPU has like 0 point something ohms, and that's normal. 0.2 ohms. Well, at least the customer can still use the laptop. Of course, cannot be used as a gaming laptop, or maybe light games like Roblox, like Minecraft, it will work. But not like heavy games. Good, let's test it one more time. No, the battery is discharged. We have 5 amps there, and that's fine. Not sure why it's not charging. I mean, it's not charging at all. But pressing the power button and the laptop it is coming on. Yeah, the board didn't retain the BIOS because there's no BIOS battery here. And the main battery is dead, so the BIOS it will get reset every time we are disconnecting the power. Wait, we don't have AM2 drive here. Yeah, okay, it's going to BIOS. Good, let me plug AM2 drive. Plug in my testing AM2 drive. Good, should be fine. Now one more time. Yeah, the SSD position is fine. The pin it will touch anyway. Let's see. And it's coming on. And probably it's loading the windows. Yeah, it's loading the windows. Yeah, it's working. Working fine. I mean, that's all what we can do in a case of like a shorted MOSFET on the GPU or VRAM. Yeah, all good. But you know what? It show me like it's charging the battery. Strange. And if we are shutting down the laptop it's off, my M2 drive it's out, it's not charging. It's not charging at all, you can see. Or maybe it's charging. I seen like 3 amps there. Yeah, it's going to the limit. Wait, 1 second. We have the power supply is getting dropped to like 13 volts. Five amps. Yeah, the first MOSFET is shorted. So we are like 2 days later, spoke with the customer. The customer it is happy with the repair, and also he want to repair the charging circuit. Now, in order to understand the fault, you see now the battery has some current. The laptop it is coming on. Yeah, we have picture and all that. But if I try to charge the battery, and like I said, I don't have the charger. So we're gonna use the power supply. So this is a very specific fault. So what do we have here? It's actually the first MOSFET being shorted. Let's switch the power supply to 19 volts. Yeah, let's use some current. Yeah, like 4 amps. So coming with the power supply, you have plus and minus. And check what happened. Check what happened with the voltage. The voltage get dropped to 14 volts. You can see? And the current is insanely high. Now, this is a power supply, a lab power supply, which has a current limit. But the normal charger doesn't have a current limit. I mean, it kind of, have a current limit, which is the max amount of current can provide. And if you go over the charger, it will just shut down. So if you plug a normal charger, the battery current, it will go insanely high. And most likely, the first, which it will get disconnected, will not be the charger, it will be the battery. The battery is getting disconnected, the laptop is working fine on the charger, but it will not charge. I mean, I cannot trigger the battery to get disconnected. Yeah, 4 amps, but probably it will get disconnected with 4 amps. Let's see. Yeah. So you see, right now, the battery got disconnected. It's taking no current. But if I power on the laptop, it will work fine. What will happen now, I'm going to take the motherboard out. We're going to prove the theory, actually, the first MOSFET is shorted. And we're going to replace that MOSFET. Just give me like 1 minute to take the board out. And the motherboard, it's out. What is here? Oh, okay. Where was the burn mark? Anyway, let's focus attention on the first two MOSFETs, which are here. So we have a fuse, first MOSFET, second MOSFET. So we can see here the configuration, fuse, first MOSFET, second MOSFET. Like I said, this is a classic fault of a shorted first MOSFET. So checking the first MOSFET. Check on the screen. So the MOSFET has like 1.8 ohms, which means it's shorted. The second MOSFET is fine. So the problem is the first MOSFET being shorted. Now let's remove the MOSFET. It's nice we have a fuse here. Did the fuse help with anything, like with this MOSFET getting shorted or with that MOSFET getting burned? No. So we removed the MOSFET. Now let's use some rosin flux. And I do have, yeah, we have a brand new MOSFET here. We're gonna use a brand new one. Channel N, good. I mean, it's not even important, like on this case, it's not even important what MOSFET we are using, because we don't have a working GPU, working dedicated GPU. Good, so the MOSFET it is soldered. Now all what is left is to test. Let's cool down the motherboard. Now plug in the battery. Battery is plugged. Minus, plus. And I seen like 10 milliamps. Let's see if it start charging. No, it's not charging. Huh? Why is not charging? Hmm? I mean, it's not taking like insane amount of current, but it's not charging. You think the battery is disconnected? Let me check. Let me lower the current actually. I want to lower the current. Yeah, plus. Yeah, the battery is disconnected. That's the reason why it's not charging. How we can activate the battery? We have to start the laptop. And probably the AC chip, it will enable the battery. Okay, plug all the connectors. Let's come with the power supply. 19 volts. One more time. Yeah. 4.6 amps. Minus. Plus. And it's not charging. Okay. Let's start the laptop. So starting the laptop, pressing the power button. Power button on and the laptop start working. But not charging, right? Okay, that's strange. Why is not charging? The battery was taking current last time. Yeah, we do have picture. Huh? Let me shut down the laptop. No, it's still not charging. And that's because the battery is not enabled. But why the battery is not enabled? Let me lower the current. Yeah. Good. No, the battery is not enabled. Do you think we fried the battery? Or actually it's not plugged in? It is plugged in. Plus, minus. Let's check the voltage. We don't have an enable pin here. No, we have clock data, plus and minus. And here we have 0.9. 0.9. Okay, let's lower the voltage. Good. Let's try one more time. That's crazy, it's taking no power at all, nothing. No, nothing. How can I fry a battery? I can't believe we are start breaking things. Why the battery is taking no current? Because the battery internal fuse is blown? Yeah, most likely. Yeah, probably. Probably they made it on purpose, you know. This fuse, it will not blow up. It will blow up from one from the battery. That's crazy. How we can reach the fuse? I mean, no, we cannot reach the fuse from here. But we can have a look. Yeah, definitely we can have a look. But wait, the battery is providing voltage. Yeah, but no current. Okay. I mean, this never happened, like, you know, the fuse to blown when you charge the battery. It has Mosfet, has current sensor. Can sense like high current, can disconnect, you know, has Mosfet, can disconnect the cells. Hey, why the fuse it will blow? Because we are recording a video. Yeah, can be. Well, have in mind this fault and be prepared for something like that. So we have the board. I'm looking to see the fuse. Probably the fuse is on the other side of the board. How can we take the board out? I can see some plastic clips here. You can see. And the fuse is here. Here is the fuse. Let's see if the fuse is good. I really doubt that, but yeah, let's check. This is a thermal fuse. The fuse is good. You can see it's a bridge here. This is a solder bridge. Yeah, this is the heater under this metal thingy under the solder. This is a heater, and when something goes wrong, the heater it will melt the solder, and the solder it will separate on one side. That's how this fuse is working. Then I'm still confused. Why the battery is not charging? Yeah, we do have. Check here. We have like 4 Mosfets. You remember we started the laptop at the beginning. So taking the power supply, ground, plus, and it's taking no current. Good. That's okay. That's fine. I'm assuming minus and plus, it's at the end, which is here. Yeah, with the plus on this side. Good. Let's charge the battery a little bit. Plus and minus. 1 amp. Yeah, I can stick the ground on the probe on the ground. Let's raise the current to like 3.8 amps. The battery is not great. I mean, check there. With 3.7 amps, the voltage is 13.2, and the limit on this one is like 12.4. We have 3 lithium cells. 12.6, sorry, 12.6 volts. And we have 13.2, so the battery has a very high internal resistance. It is possible the battery just got locked now when we came with high current on the beginning of the second part of the video. Yeah. So if we are trying now here, no, it's not. It's not taking current. That's crazy. Okay. What can I say? Yeah, the battery got locked. Let me grab the NLBA. Now, it's nothing to be ashamed by things which are going wrong. I mean, not only can go wrong, but it will go wrong on some point. All you have to do is to be prepared. So what do we need? We need 3 wires, because you know the battery has some voltage. We need clock, data, and ground. So we have the 3 wires, and it's working. And the battery is unlocked? Huh? Let me bring the... But how can I bring it? 1 second. I think, yeah, here. So check there. The battery is unlocked. You can see it? I can't make it bigger. I think I can bring the NLBA here. Yeah. You can see the battery is unlocked. That's crazy. Capacity. He's saying it's fully charged and this battery is not fully charged. Health is good. The cells are balanced, quite a good balance. And what I believe we have here, it's actually a firmware battery error. Because it's telling me it's fully charged when the battery has like what, like 0.9 from what we checked? Yeah. But it has to say the voltage here. Voltage 11.4. That's not fully charged. So in order to check this, we need actually one more wire, and the plus wire. Yeah, let's connect the plus wire. And the plus wire is connected, you can't see, sorry. Yeah, plus wire. Now, yeah, the battery is still connected. Let's go to charge. Let's start charging. It's not charging. Check that. It's not charging. It's not charging. Told you. Discharging. Discharging is working. Ha. Huh? No. No. It's no current is provided. You can see? Nothing. Good. Reset. Let's see. The chip is supported. Good. Next. Read chip info. And we do have a PF status. We have an error there, you can see. Now, I didn't bother to learn what this means. But anyway, what we can do is unseal. Let's wait. Good. Clear chip errors. Error clear. Read. We have PF status. We don't have any error there. Then seal exit boot. And it's fine. PF status is only 0. Now if we are going to charge, charge, start charging. Check here. I can hear the fan. Charging the battery. Okay, we have no error. It's saying it's charging the battery, but it's pushing no current into the battery. So it's still something wrong with this battery. I mean, check here, we have no error, nothing. But still not working. Discharging. Discharging, no current, nothing. No, I swear this looks like a burnt fuse. That's crazy. I can't believe it burned my fuse. This fuse was not burned because we fixed the error. Yeah, we fixed the error. We had like a firmware error. But now the fuse is burned. Check there. You can see. So the solder got separated. That's crazy. So in the moment we fix the error, the BQ chip blow up the fuse. Ha! What a prick. Now, how we can fix the fuse? Very simple, yeah? All you need is solder. That's all. So we have to rebuild the thingy, and it's done, yeah? So the fuse is repaired. You don't need wires, you need solder because the fuse has a heater. Now if I press read capacity, it gives me like 50% charge state. So we have no error. So that error could be the problem. Charge, start charging, and check here. Yeah, check here. It's taking current. So now we are charging the battery. We can see the voltage on the cell, so you can see actually the battery is taking current. We can charge the battery. You see the current is going up, the voltage is going up. We can probably even discharge the battery. Discharge, start discharging. And check here the current. Actually, it is providing current. But one more time, yeah, the error, it was regarding the capacity. So that firmware error was looking like, okay, the battery is fully charged, so I cannot charge. but also cannot be discharged. So right now this battery is repaired because it's reporting the charge state of the battery right. We have 53% and the voltage is 11.5. Okay, good. So we fixed the battery. Can't believe this is my luck. Let me disconnect. So one more time, this battery was good. When we start the second part of the video, the battery, it was good. We push current with the power supply, remember? Then the battery catch a firmware error. Yeah, that's what it was, a firmware error. The battery, the fuse was not burned at the beginning. The fuse of the battery was not burned. It was only that error. And we fixed the error, the fuse blew up. Let me bring the laptop here. So the laptop is here, plug in the battery. Now if I'm coming with the power supply, let me set up some high current here. Yeah, 4.7 amps. So on the same way, minus and plus here. Check there, check there, check there. Huh? 1.6 amps. You can see the charging current there? Yeah, it's charging with 1.6 amps. Yeah, and it's charging fine. I mean, how unlucky you have to be to something like that happen? Just to understand the irony, yeah? The first Mosfet, it was shorted. We replaced the Mosfet and the battery firmware goes wrong. These things can happen. You have to be prepared. I mean, I didn't expect that. Exactly when I'm doing a video happened. Happened before? No, I don't remember these kind of things to happen before. But it's always a beginning. Just, give me a few minutes to put the screws and everything back. Okay, everything is back in place. Let's do last test. So minus, plus, and the battery is charging fine, 1.6 amps. Pressing the power button. The laptop, it is coming on. Now it's taking like 2.8 amps, 3 amps, which is fine. And we have picture. We can see on the BIOS is saying charging. If I take the power supply, it is holding the battery, it is holding the power. And obviously, it's reporting exactly the same amount of charge like on the NLBA. Plus back here, and it's charging. You can see there. So total current is like 3.3 amps. I think this laptop, it is fixed. Okay, so I'm happy I helped the customer. It was an unfortunate event, which I'm happy I recorded, just to understand how the things can go wrong, even if it has no logic. You cannot burn a battery. It's impossible. Yeah, you have has a current sensor, has Mosfet. So as soon as you pass the current, let's say you short the battery and you come with overcurrent from a power supply, the battery will get disconnected because it has a current sensor inside. So you cannot burn a battery. It's made like in case like any like shorted motherboard. It's made to the battery not get shorted. But again, this is rare. So what we did, we came like current. The voltage goes down on the power supply because the first Mosfet was shorted, and the battery catch a firmware error. Yeah. My luck was the NLBA. I found to be really helpful on these kind of cases when the things goes wrong. I mean, not on when the things goes wrong, when we have laptop which they are not working without the battery, and you have a battery which I'm not saying is faulty. Let's say it has 0 volts and it's not charging. You will find that the battery is not charging with the power supply because it's not enabled by the EC chip. And on that point, the NLB is very helpful. I will, in any case, I'll leave a link on the description if you are interested. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. And one more time, don't feel bad, because the things, it will go wrong on some point. All you have to do is to be prepared. Yeah, when something like that happen. See you on the next one. Bye.